Okay, here is a question, and I have sort of proved this. Okay, so just have to go back to पिछले हमने एक दो जो arguments देखे, and you'll see is. So the statement says that if the diameter of a graph, और diameter अभी तक हमने define नहीं किया. Okay, diameter यहाँ पे define हुआ है. Diameter of a graph is the maximum distance between a pair of vertices in the graph. Okay, so अभी तक हमने जो graph देखे हैं उसके diameters देख लेते हैं. वो काफी देर होगी हमने कोई. Okay, so for example, this is your graph. तो इसका जो diameter है versus diameter. What's its diameter? What do you guys think?
A to C.
I think not. So the thing is, इस केस में diameter थोड़ा सा मुश्किल है. मैं अभी आपको बताता हूँ इसको. We'll come back to this problem. Let's go to some other problem. What's the diameter in this case? इस केस में क्या diameter है? So diameter in this case is obvious. It's 3. Okay, so you can start at this vertex, go to here and here and here. Okay, so you can go to from this vertex to this vertex in 3 steps, and that's the longest path that you can find. Okay, इससे बड़ा कोई path exist नहीं करता. Let's see if there is another example before I go to the troubling example. So in यहाँ पे the diameter is 3 again. Okay, is it?
Yes, sir.
Are you sure?
Yes, 1 to 2 to 4.
Sir, isn't it 2?
It's 2 in here. It's not 3. So the thing is, whenever you need to, the distance mean it's the length of the shortest path. Okay, so the distance from 1 to 3 is just 1. You can't choose the longer path. You have
That's 2. Yes.
Yeah, you have to choose the shortest path. So the diameter in this case is 2. You can go from 1 to 4 in 2 steps. इससे ज़्यादा बड़ा कोई path exist नहीं करता. Shortest path नहीं exist करता. Okay, so diameter in this case is 2. Diameter in this case is 2 as well. Okay, let's see if there is any other thing. What's the diameter in this case?
Which one?
C5.
I think
5.
2. 2, yes.
It's 2 in here as well, because pick any pair of vertices, you can get there in 2 steps. Okay, यहाँ पे कोई इस तरह की 2 vertices नहीं है जिसमें आपको 2 से ज़्यादा steps चाहिए. So you can go from V1 to V2 in 1 step, V1 to V3 in 2 steps, V1 to V4 in 2 steps. Okay, that's it. You can't take more than 2 steps when you use shortest path. Okay, let me give you an example of path जिसको हम K33 कहते हैं. Okay, so K33 is a complete bipartite graph on 3 vertices in X, 3 vertices in Y. Okay, and they are all connected to each other. What's the diameter of this graph?
2.
Yeah, the diameter in this case is 2 as well, because you can go from a vertex in here to every vertex in 1 step,
Yes, sir.
and you can come back to every other vertex in 2 step. Okay, so the diameter is 2 in this case. Okay, where was that graph? So for example, इस ग्राफ में ये वाला जो ग्राफ है, इस ग्राफ में डायमीटर क्या है?
1.
Turns out इस ग्राफ का जो डायमीटर है वो इन्फिनिट है, because there is a vertex which takes infinite amount of time to get to another vertex. Okay, so
Only
it's
one
an
point?
yeah.
Only one vertex.
So you can so the thing is, you are looking for the longest pair of vertices, the farthest apart vertices. Okay, so the farthest apart vertices जो आपके पास हैं वो ये 2 vertices हैं, and there is the distance between them is infinite.
We can't go there, so infinite. Okay.
Okay, and the same thing is true about this graph as well. Okay, you can
Yes, sir.
start at D. From D to A, you can't reach in a finite amount of time. Okay,
Yes, sir.
awesome. I hope the definition of the diameter is clear, because we have a problem here. The problem says that if G has diameter more than 3, greater than, greater than 3, let's call it diam of G is more than 3, then it implies that the diameter of G complement is less than 3. So in other words, again मैंने आपको कहा है कि to solve a problem जिसके अंदर आपने कुछ prove करना है, you start with the definitions. Definitions are your best friends in this case. Okay, these you should always start with that. Diameter is more than 3. What does it mean? It means that there is a path जिसमें आपके पास 1 2 3 there is a path of length 4. कम से कम ये चीज एग्जिस्ट करती होगी. Okay, and उसको नाम भी दे दो. Let's call it B, C, D, and E. Okay, so there must exist 5 vertices जिसके दरमियान कोई शॉर्ट कटिंग नहीं है. There is no path from B to D or C to E. Okay, this is what it means for a graph to have a diameter at least more than 3. Okay, then what do? You take a complement of this graph and then you arrive at a graph which has diameter less than 3. And what does it mean for a graph to have diameter less than 3? It means that for every vertex to every other vertex you can reach in 2 steps. Okay, you take 2 arbitrary vertices and you can get there in 2 steps. Okay, and you can go from here to there in when you're taking the complement. So think about it. Let me know. You have about 30 seconds to 1 minute to think about it. Any ideas?
So I guess we can say that the two vertices which have the maximum distance between them, when we
Yeah.
take their complement, um, the,
They
the
would be
distance,
adjusted.
yeah,
Okay. Yeah. A and E are adjacent. Then what?
Then that reduce the length by 1. They will have a path of length 1.
Yeah, that says something about those 2 vertices, which were farther apart in the original graph, right? It does not say anything about other vertices, right? So, for example, if I have a pair of vertices who are at distance, I don't know, nothing to each other, okay? इस तरह की कोई vertices थी. What does it say about them in the complement graph? ये तो सारे edges सारे remove हो जाएंगे ना?
Yes.
So diameter does not say that the whole graph is मतलब बहुत मतलब एक लाइन में सारी वर्टिसेस हैं, ऐसा तो नहीं है ना. डायमीटर जस्ट सेज के कोई एक वर्टेक्स है जो किसी एक और वर्टेक्स से डिस्टेंस एटलीस्ट 4 है. ओके, सो इट्स पॉसिबल कि यहाँ पे क्लीक्स भी हों, बहुत ज़्यादा क्लस्टर्ड वर्टिसेस भी हों कहीं पे, which will have all their edges removed in the complement. So I'm gonna leave it here. I'm not gonna solve this. I'm gonna leave it for you to do on your homework. Okay, but what I'm going to leave you with is a clue, and the clue is that these two vertices play a very important role: the B vertex and the D vertex. Okay, they will play a very important role in the complement. Okay, any questions? You will get your homework sometime in the evening today, and I'm gonna give you about a week to solve it by next Thursday. And it's mostly going to be on graphs. Okay. And I'm always here to send me. You can send me an email, and we can do a Zoom session and discuss the problems on the homework. Okay. Last chance. Any questions?
Will this turn into a recursive problem?
I think not.
Okay.
I think not. It's just, I think it's pure logic. It's, you think about it, and there's an argument which should come to your mind. No tricks there.
Okay.
All right, people. I'll see you on Monday. Thanks. Bye-bye.